Okay. 3.4. Okay. One of the things is finding the distance from a point to a line. We have actually done this already in that we've found the distance between 2 points. If we're going for the distance between a point and a line, it's got to be a perpendicular, right? Because that's the short. See how this can't be the distance because that's longer, and this can't be the distance because that's longer. It's got to be perpendicular like this. So once you have the place, you can actually, let me draw this. If you have it graphed, you're in luck because, check this out, it makes a triangle. See the triangle here? This distance, 1, 2, 3, 4. This distance is, oh, hold on a second, let me clear that and draw it with the line tool because I'm not. Okay, so this goes to here and this goes to here. Right? See the right triangle? You can use the distance formula, but if you have it graphed, you can count the squares. And that's what I'm going to do. 1, 2, 3, 4, that's 4. 1, 2, 3, 4, that's 4. And that's where this comes from right here. It's the square root of 4 squared plus 4 squared. So that's, this 32 came from 16 plus 16. And they used a calculator and came up with it being about 5.7. So this is old. We've already used the distance formula. We know how to do this. So what else do they have for us? What else they have for us? They show us the way you construct a perpendicular line. Notice they make a arc from a point, from the point where it's supposed to go, and then they make the same arc below, and then they draw a line through it like that. You're not going to have to do that here. Let's see. Okay, here's where the meat is. Linear pair perpendicular theorem. Check this out. It's basically saying if angle 1 and angle 2 are equal to each other, then that has to be a right angle. And here's why. If they're equal to each other, if I have two things that add up to 90 and they're equal to, that add up to 180 and they're equal to each other, they both each have to be 90, right? If x plus x makes 180, that's 2x that makes 180. X has to be 90. Oh, my handwriting's so bad. X has to equal 90, right? They add up to 180 and they're equal. They both have to be 90. This is probably intuitive to you as well. You know when you're moving things around, if you get this angle to be a right angle, it automatically makes this one to be a right angle. As a matter of fact, if the lines are parallel, if you got one right angle, it turns out you've got 8. If the lines are parallel, they all end up being equal to each other. Same thing happening over here. If two lines are perpendicular to the same line, it makes them parallel. Because look, see how it's, if they're both perpendicular to this line, these are corresponding angles, right? They're equal to each other, the lines are parallel. We just talked about this. Proving the perpendicular transversal theorem. Let's see. If they told us that the lines are parallel, and so we know that these lines are parallel, and we're giving that J and K is perpendicular, then that makes this angle 90. But then 2 and 6 are equal to each other, which makes that one 90. So if it's 90, that makes it perpendicular. That's all they're saying. Okay. Oh, and then there we go to exercises. There's some finding distance. They're just going to ask you about that construction.